Okay, so since this one doesn't have a watch it button, I thought I'd make a video for this problem because it's a little bit tricky. So it starts out saying the magnitude of a velocity vector is called speed. Suppose that a wind is blowing from the direction north 45 degrees west at a speed of 30 kilometers per hour. So it says this means that the direction from which the wind blows is 45 degrees west of the northerly direction. So say I just put in a kind of coordinate system here. Okay, so here's north, south, west, east. Here's the tricky part of this problem, is that they say the wind blows from that direction. So 45 degrees west of north, is just halfway between north and west, right? But it's blowing from that direction. So say your plane, like your plane is right here. That's a horrible plane, but okay. The wind is blowing this way. It's coming from this direction, so it's acting on the plane like this. And a pilot is steering a plane, so okay, so I don't have it heading the right way, in the direction north 60 degrees east. So that means it's 60 degrees east of north. So he's steering the plane 60 degrees east of north. So he's heading this way. So my plane should be more oriented towards heading that way. And let's see, the wind speed is 30 kilometers per hour. And the reading on his speedometer is, he set it to be 300 kilometers per hour. So he's not going to be able to go this way, even though he steers that way, because the wind is affecting and blowing him a little bit off course. So it says the true course or track of the plane is the direction of the resultant of the velocity vectors. And remember, resultant just means sum. And so we want to find the sum of these vectors. So I want to find their vertical and horizontal components. Okay, so for the wind, so when I write it as a vector, I know its magnitude is 30, and the x component is going to the right, so it's going to be in the positive direction. And here it doesn't really matter, 45 degrees either way. So it's, and for the horizontal, it will be the cosine of 45 degrees. And the y component is negative because it's pointing downward. So, oops, cosine 45 degrees I, and then minus pointing down. And then for the plane, I'll just call it P. Although normally you would call this, really you would probably call it V sub W, the velocity of the wind, and you would call this V sub P, the velocity of the plane. I'm just kind of being a little bit lax in my use of vector names here. So the magnitude they tell us is 300. And now you want to be a little bit careful about where you use sine and cosine, or which angle you use. If I want the horizontal component, if you were to make this triangle, you wouldn't use 60 degrees because this triangle, the angle right here, the adjacent side would be adjacent to a 30-degree angle, not a 60-degree angle. So if you wanted to use 60 degrees, it would just be the opposite side. You could also draw a triangle right here, but then the horizontal component is opposite the 60-degree angle. So it's either going to be sine of 60, I, or cosine of 30, J. I'll just think of using the x-axis and think of this angle as being 30 degrees. So it would be cosine of 30, I, and that's positive because it's going to the right, and the vertical component is positive as well as pointing up. So plus sine of 30 degrees, J. And then they say to do your answers to 1 decimal place. So 30 times cosine 45, just doing that on my calculator. And I get 21.2. And then minus, well, sine of 45 is the same as cosine of 45, so we just get minus 21.2 J. And now for the plane, so 300 times cosine 30 is 259.8. That's I. Now, keep in mind, your numbers might be different that randomly generates these numbers. So don't just type in the answers I get, because you might not have 30 and 300 in your problem. And then 300 times, well, sine of 30 is a half. So 300 times a half is 150. So the resultant velocity vector, because they say the direction of the resultant, so resultant just means sum. So the resultant velocity is you just add corresponding components. So 21 plus 0.2 plus 259.8 is 281. I plus negative 21.2 plus 150. Is 128.8. Okay, so that's the resultant velocity. They say find the true course and the ground speed. The ground speed is the magnitude of the resultant, so I'm just going to use S for speed. So magnitude is just the square root of the sum of the squares of the components. So square root of 281 squared plus 128.8 squared. And I get 309.1. And that would be kilometers per hour. So this is the ground speed. And then the true course. So true course is really the direction it's heading. So, okay, so let's think about what that vector looks like. And they want us to use this bearing notation. How many degrees east of north will it be? So let's just think about what that vector looks like. So we go 281 units over. Let me do this in a different color so it shows up. So this is 281 units, and then we go up 128.8. So that's like the resultant velocity vector, and here are its horizontal and vertical components. We want to find this angle. But if we look at this triangle right here, we can use trig to find this angle. I'll just call it theta right now. And then our answer will be 90 minus whatever we get. And we have the opposite side and the adjacent side, so we can just use the tangent function. So tan theta is opposite over adjacent. And so theta will be inverse tangent of that. and I get 24.6, which means the angle we're really looking for is 90 minus that, or 65.4. So that would be the angle that we would put in here, 65.4 degrees east of north. And then our ground speed was 309.1 kilometers per hour.